Good morning, friends. In this lecture, we are going to discuss about the projectile motion, which is the example of the two-dimensional motion. This is the pictorial representation for the projectile motion. We know the projectile motion is the two-dimensional motion, which is explained with the help of x and y axis. The symbols which are used in the diagram, it is shown here, like u as initial velocity, o as point of projection, ux, that is horizontal component of initial velocity, uy, vertical component of initial velocity, theta, angle of projection, OAPBQ, it is a trajectory of the projectile. R is capital R, horizontal range of the projectile. Small d, it is the maximum height of the projectile, or letter H, it is also used. Capital P, that is a point at the maximum height. Now, we want to discuss here some basic terminologies. What is meant by the projectile? Now, object thrown in air with initial velocity in any direction, making some angle with a horizontal and moving freely under the action of the gravity. Means object is moving in the air under the influence of the gravitational force. For example, the bullet fired from the gun and a football kick in air. Point of projection. You have seen in the diagram, point O, it is the point of projection. The point from which the body is projected in air, it is called the point of projection. Velocity of a projection, in the diagram you have seen u, it is a symbol for the velocity of projection. The velocity with which a body is projected, it is called the velocity of the projection. Angle of projection, it is denoted with a theta. The angle made by velocity of a projection with the horizontal trajectory, that is the path traveled by the projectile, the path followed by the projectile in a space, that is called as the trajectory. Time of flight, it is shown with capital T, that is time taken by the projectile to cover the entire trajectory. Time of ascent, that is a time taken by the projectile to reach at a maximum height from the point of projection. Time of descent, that is time taken by the projectile to reach at original plane of the projection from the maximum height. Horizontal range, which is denoted as capital R, that is the horizontal distance covered by the projectile in time of flight. Maximum height, it is denoted with a small d, that is the maximum vertical distance traveled by the projectile from the horizontal plane. Now, we want to discuss the detailed expressions for the projectile motion. You have to observe this diagram very carefully, in which the different components are shown. If you observe here, then this path is given as OAB, and this is the vertical distance, which is the maximum height. This is the horizontal distance, which is called as the range. This theta, it is called as the angle of projection. initial velocity u, it is divided into two components, that is ux and uy. This horizontal component ux, it is given with u cos theta, and vertical component uy, it is given with u sin theta. At maximum height, you will find the vertical component of the velocity, it will becomes a 0. Similarly, when the object is moving in downward direction, you will find the horizontal component of the velocity, it is remains constant. Means the velocity in vertical direction goes on changing because of the gravitational force. Okay, so you will find here ux, that is a component of the velocity along x-axis, and uy, that is a component of velocity along x-axis, along y-axis. Already we have seen here this component along x-axis, it remains constant. So acceleration in this direction, definitely it is a 0 because velocity is constant. Now ay, it is an acceleration along the y-axis, and this acceleration is denoted with minus g because this acceleration is taken opposite to the gravitational force. Okay, it is opposite to the gravitational force. Okay, so you will get this idea from this diagram. Now we want to find out the expressions for the projectile motion. Now in the diagram already we have seen the body is projected with initial velocity u bar, and theta is the angle of projection from the point O, which is the intersection of the coordinate x and y axis. Already we have seen the projectile motion is the two-dimensional motion. The initial velocity can be resolved into two components. One is the horizontal component along x-axis, which is denoted as ux, which is u cos theta. Another component is vertical, that is along y-axis, denoted as uy, which is equal to u sin theta. The horizontal component, it is remains constant because the absence of force in that direction. The vertical component of the velocity, it will get changed according to this equation. We know this is the equation of motion, that is the first equation of motion, that is v is equal to u plus at, but it is used along y-axis, so it is written as vy is equal to uy plus ay into t. Now in this equation, ay is nothing but minus g, and uy, which is the initial velocity, it is u sin theta, and this vy, it is the final velocity after certain interval of time. Now the component of the velocity, which is along the y-axis after time t, it is given according to this. We know the velocity along x-axis, it remains constant, so the final velocity, which is a vx after time interval t, it will also remains the same. Now vy, which is the velocity after time t, it is nothing but uy minus gt. So you have to put this value of ay is equal to minus g and uy is equal to u sin theta in this equation, which is actually this equation. Okay, so you will find vy is equal to uy minus gt, ay is equal to minus g, and again uy is replaced with u sin theta. So you will get, this is very important equation, equation 2. So you will find this is a velocity along x-axis, equation 1, and velocity along y-axis, that is equation 2. Similarly, the component of the displacement of the projectile, it can be also taken after time t, which is denoted as Sx and Sy. Now we know Sx, that is a displacement along the x-axis, and displacement is nothing but velocity into time. So along the x-axis, velocity is u cos theta and time is taken as t. So this is a very important expression of Sx, that is a displacement along the y-axis. Similarly, you will find here that is a displacement along the y-axis, which is given here with the help of the explanation of the second kinematical equation, that is S is equal to ut plus half at square. But you will get here that it changes Sy, that is a displacement along the y-axis. U is replaced with u sine theta because it is the velocity along the vertical direction. Minus, this minus sign is for, that is S is equal to ut plus half at square. So instead of a, we can use here minus g, that already we have shown here along the vertical direction. So this equation will get changed as Sy, that is a displacement along the y-axis. So you should remember that is the expression for the velocity along x and y-axis from equation 1 and 2, and the equations for the displacement along x and y-axis, it is given from equation 3 and 4. Now we can use this equation 1, equation 2, equation 3 and equation 4 as we require. Now we want to explain the expression for the time of flight. Now already we have seen what is meant by the time of flight, that is time taken by the projectile to cover the entire trajectory. It is called as the time of flight. It is denoted with the capital T, as we know. Now, as if we find out the time of ascent, then easily we can make an expression for the time of flight. So if we consider the maximum height position, then velocity, it will become a 0, Vy is equal to 0, and time required for this, that is the time of ascent, which is denoted with T0. So here we are considering the maximum height, that is the point P. Okay, velocity at that point is 0 and time required, it is taken as the small t, which is a T0. Now here we can take the help of the second equation, which is related to the vertical axis. Already this equation we have seen, and in this equation now we can put the values. आता या इक्वेशन मध्ये 2 मध्ये we can put this value Vy is equal to 0 and small t is equal to T0. So this equation 2, it will become left hand side 0, which is equal to u sine theta minus g T0. Now we can find out the T0. So you will find u sine theta is equal to g T0. We can make the equation for T0 u sine theta divided by g. So this is the expression for the time of ascent, and as we know that total time, which is called as the time of flight, it is the 2 times of the time of ascent. It is double of the time of ascent. So we using this relation, and the final equation which you have, that is capital T, which is equal to 2u sine theta divided by g. This is the expression for the time of flight of the projectile. So you should remember this equation, which is a very important, that is capital T, that is time of flight. Capital T is equal to 2u sine theta divided by g. Similarly, we can find out the another expression for the horizontal range of the projectile. In the diagram, we have seen the horizontal range is shown with a letter capital R, and that is the maximum distance traveled by the projectile along the x-axis, that already we know, that is called as the horizontal range. Capital R, it is a symbol for that. Now this horizontal distance, which is traveled by the particle in time capital T, that is total time required for the projectile to cover the entire trajectory. So we can use the third equation along the x-axis, because horizontal range is calculated along the x-axis in terms of distance. So we have selected this third equation, and in this third equation we can replace the symbols, like on the left hand side sx, that is a displacement along x-axis, it is replaced with this capital R. This u cos theta, it is nothing but ux into t. Now in this equation again you can put the value, that is capital R is equal to ux is u cos theta, and this small t, it is nothing but actually capital T, okay, which is 2 times of t0. Now as we know the value of t0, by using this value of t0, that is a time of ascent, this equation will get changed. R is equal to u cos theta 2u sine theta divided by g. Now if you observe this, then in the denominator you will find u square 2 sine theta cos theta divided by g. If we use the one mathematical relation for this bracket, that is a 2 sine theta cos theta, which is equal to sine 2 theta. So you have the relation capital R is equal to u square sine 2 theta divided by small g. This is an expression for the horizontal range of the projectile. Now here, if you observe, this horizontal ranges depend upon the value of theta, which is called as the angle of projection. Now we want to find out what is the value of maximum horizontal range. So we know it depends upon the value of theta. So if sine 2 theta is equal to 1, and it is a possible if 2 theta is equal to 90 degree, means sine 90 is equal to 1, as we know. So 2 theta must be 90, means theta must be 45 degree. So this maximum horizontal range can be calculated by keeping the angle of projection as the 45 degree. And if we consider theta is equal to 45, then you have the relation of the maximum range, which is equal to u square divided by g. Again, you have to remember these two very important expressions. One is for the horizontal range, capital R is equal to u square sine 2 theta divided by g. And second important equation, that is for the maximum horizontal range, that is R max is equal to u square divided by g. Now we are going to explain the expression for the maximum height. Now we know maximum height is taken along the y-axis. So it is the distance traveled along the vertical direction in time t0. Now we know t0, it is a time for ascent. So here we can take the help of the distance, means the displacement. So we can use the equation number 4, that is The equation 4, which already we know, that is a displacement along the y-axis, which is a u sine theta t minus half of g t square. Now in this equation 4, we can put the values like t is replaced with t0, the small t is replaced with t0, and sy, it is replaced with, that is the displacement along the vertical direction, which is replaced with capital H, which is a symbol for the height. Okay, so H is equal to u sine theta t0 minus half of g t0 square. Now here we can put the value of the t0. It is very simple. You have to put the value of t0 and t0 square. So this equation will become H is equal to u sine theta. For t0 we can write u sine theta divided by g minus half into g, and it is a square. So u sine theta divided by g bracket square. Okay. So we can solve this now. So after solving this, you will get here, that is in the denominator you will find it is u square sine square theta, u square sine square theta. Here also you will find it is a square, so u square sine square theta. Okay. Now divided by, here it is a g, and here it is divided by, so this g and this g, actually it is a g square, so one g will left in the denominator, and this g, actually it is 2 times of g here, 2 times of g, so you will find it is a 2g. So final equation you have capital H is equal to u square sine square theta divided by 2g. As we know, this value is nothing but uy, which is the velocity along the y-axis. So it is written as uy square divided by 2g. Okay. So this is expression for the maximum height of projectile. Again, you will find in this equation of H, the important role is of theta, that is nothing but the angle of projection. So we can find out now the relation between the maximum range and maximum height of the projectile. As we know, it is a taken for the angle of projection, which is equal to 45 degree. So if we put the value theta is equal to 45, then you will find this is an expression for the maximum range. It is u square divided by g. And in this equation of capital H, if you put this value of theta is equal to 45, then you will find sine 45 is equal to 1 divided by root 2. And again it is a square, so it will become 1 divided by 2. So this equation of height, it will get changed for H max, which is equal to u square divided by 4g. Now this is equation for maximum range. This is equation for maximum height. We want to find out the relation. So in case of this maximum height, you can put the value of this u square divided by g as the R max. So in the denominator you will find R max divided by 4. Or you can calculate R max is equal to 4 times of H max. Okay. So this is the important relation between the maximum range and maximum height. So you should remember these two very important equation. One is for the height of the projectile, which is given u square sine square theta divided by 2g. And the second equation, which is a very important relation between the maximum range and maximum height of the projectile, that is H max is equal to R max divided by 4. Now the final equation which we want to find out, that is equation of motion for a projectile. Now this equation gives you the path which is followed by the projectile. It is the parabolic one. So it is called as the equation of motion. It gives the relation between the displacement along the vertical and the horizontal direction. So we can use the equations 3 and 4, and we can eliminate the factor of time. Now let us discuss Sx and Sy. These are the displacement along x and y axis, which already we have seen that equation 3 and 4. Now as motion is starts from x is equal to 0, so Sx, that is a displacement along x-axis, it is considered as x, and Sy, displacement along the y-axis, it is considered as y. So Sx is replaced with x and Sy is replaced with y. So the third equation will get changed. Sx is equal to u cos theta into t. So we can find out the equation for small t, that is a time factor. So Sx divided by u cos theta. Now Sx is replaced with x. So this equation will become t is equal to x upon u cos theta. Now we can take the equation number 4. This Sy, it is replaced with y, which is equal to u sin theta into t minus half g t square. Now we can put the value of t and the t square from this equation in case of this y. The next step will become y is equal to u sin theta. We can put the value of small t as x divided by u cos theta minus half into g, here small t, the whole bracket square, x divided by u cos theta. Now if you solve this, then you will find here u get cancelled, sin upon cos, it is a tan theta into x minus this half as it is, and this is the whole bracket square. So x square from the denominator is taken as outside, so you will find g is here, and in the denominator again it is a square, u square cos square theta. Now if you observe this equation, then this equation is written in terms of y is equal to a into x plus b into x square. As capital A, it is a taken for one constant tan theta, and b, it is a taken for the constant minus half into g divided by u square cos square theta. So this equation of the motion, this is the equation of trajectory of the projectile. This equation, it is in the form of the equation of parabola, which already we have written here. So we can say the trajectory of the projectile is a parabola, means the projectile motion is nothing but the parabolic path motion.